a quiet archive record. Tonight, we're stepping into a slow unfolding. Settle in, let the outside world dissolve, and gently descend into tonight's world. For decades, astronomers have watched the sky for visitors from beyond our solar system. Most things we see are familiar. Rocks and ice that formed with the sun, moving in paths we can predict. But a few times, something has arrived on a path that does not belong here. These rare passers-by move too fast to be captured by the sun's gravity. They come from deep interstellar space. The evidence is in their speed, their direction, and the shape of their orbit. In this episode, we follow the timeline of every interstellar object tracked in history, what we measured, what we learned, and why the world briefly wondered if one of them might be more than a natural rock. Tonight, we go through all interstellar objects in history. In the language of astronomy, most small bodies in the solar system follow a simple rule. If you map their path around the sun, the orbit is an ellipse. It may be stretched out, tilted, or wide, but it is still closed. A closed orbit means the object is bound to the sun. It is a long-term resident, even if its period is thousands of years. Interstellar objects break that rule. Their path is not closed. It is an open curve called a hyperbola. That word sounds dramatic, but it has a clear meaning. The object arrives with enough speed that the sun cannot hold it. It swings past, then keeps going. If nothing slows it down, it will never return. To see why this matters, imagine throwing a stone into the air. If you throw it gently, gravity pulls it back. If you throw it hard enough to escape Earth, it never comes back. For the sun, the escape speed depends on distance. Far from the sun, it is easier to escape. Near the sun, it is harder. Interstellar objects are like stones thrown from another star system, arriving already above the sun's escape speed at that distance. For a long time, interstellar objects were expected in theory, but never confirmed in practice. Astronomers believed they should exist. When star systems form, they do not keep all their debris. Planets grow, small bodies collide. Some objects are flung outward by giant planets. Many of those ejected bodies should wander the galaxy. So the idea was simple. Space between stars should contain countless small travelers. But detecting them is not simple. They are small. They are dark. They move fast. They come with no warning. By the time we notice one, it may already be leaving. Detection requires wide field surveys that scan the sky again and again, looking for anything that changes position. It also requires fast follow-up, because the window for detailed study can be weeks or months, not years. In the modern era, several survey programs changed what was possible. Telescopes began to automate discovery. Cameras became large and sensitive. Computers became quick enough to compare images across nights. When this machinery started to run at scale, the first confirmed interstellar object finally appeared. Its name was strange and poetic, drawn from Hawaiian, but the story it started was loud, bright, and global. The first confirmed visitor was called Oumuamua. The one eye part was historic. It meant the first object given an interstellar designation. Before that, we had comets, asteroids, and the usual types. I was new. It marked a new category. The name Oumuamua is often translated as something like a messenger or a scout arriving first. It fit the moment. The object was discovered in October 2017. It was found by the Pan-STARRS survey in Hawaii. Pan-STARRS stands for Panoramic Survey Telescope and Rapid Response System. It is designed to scan large areas of sky, often to find near-Earth objects. When Pan-STARRS detected Oumuamua, it looked like a faint point of light moving against the background stars. That is how most small bodies look at discovery. But when astronomers computed its orbit, they saw something that did not fit the normal solar system pattern. The path was hyperbolic. The object was unbound. The calculation was not subtle. The object was traveling too fast. Its eccentricity, a measure of how open the orbit is, was greater than 1. That is the dividing line. Above 1, the orbit is hyperbolic. In simple terms, it was not from here. As news spread, the story had 2 tracks running at once. One track was careful and technical. It focused on measurements, brightness, color, rotation, and orbit. The other track was emotional and imaginative. It asked a question that has been asked for generations. If something is coming from another star, could it be artificial? That question did not come from nowhere. It was tied to a long cultural history of UFO stories and popular science fiction. But with Oumuamua, there was also a specific scientific reason it seemed tempting. Oumuamua behaved in ways that were not completely expected. The first unusual feature was its shape, inferred from how its brightness changed. As it rotated, it brightened and dimmed dramatically. That usually means an object is elongated. If you spin a long, thin object, the amount of sunlight it reflects toward Earth changes a lot. If you spin a more round object, the change is smaller. In Oumuamua's case, the change was very large. Early interpretations suggested it might be extremely stretched out, perhaps cigar-like. Later work suggested other possible shapes, including a pancake-like form. The core point remained. It was not an ordinary round rock. The second unusual feature was its lack of a visible comet tail. Many small bodies that come from far away are icy. When they get close to the sun, the ice can heat and release gas and dust. This outgassing can create a coma and tail. Oumuamua did not show a clear tail in the images that were taken, so it looked more like an asteroid than a comet. And yet there was a third feature that complicated that view. Its motion showed a small but measurable non-gravitational acceleration. That is a technical phrase, but the idea is simple. If an object follows a path set only by gravity, we can predict its position with great accuracy. If it deviates, we look for additional forces. For comets, the extra force is often outgassing. Gas jets act like tiny thrusters. For Oumuamua, astronomers reported a slight push away from the sun, beyond what gravity alone would produce. At first glance, outgassing seemed like an answer, but outgassing typically creates visible dust or gas. Here, there was no strong visual evidence of that. This gap between the observed acceleration and the lack of a visible comet signature created a space for debate. And where debate exists, speculation rushes in. For some, the story became a modern version of an old theme. A mysterious object that might be a probe. A few high-profile voices discussed this possibility openly. The most famous was Avi Loeb, an astronomer who argued that an artificial origin should be considered, not dismissed. He suggested ideas like a thin, reflective structure pushed by sunlight, like a solar sail. To many people, that concept sounded like a neat bridge between science and science fiction. It was a clean mechanism. Sunlight can exert pressure. A thin object could accelerate. But to other scientists, the simpler answer remained the right starting point. Natural explanations were proposed. Some models suggested that Oumuamua could be a comet-like body without gassing that was hard to detect, perhaps releasing mostly hydrogen, which would not be easily seen. Others proposed that it could be a fragment of a larger object or a porous aggregate that reacted in an unusual way. The details of these proposals varied, but they shared a philosophy. When you see something strange, you first ask how nature might do it. Still, the public attention was understandable. Oumuamua was the first confirmed interstellar visitor. It was discovered after it had already passed its closest point to the sun. That meant the best time to observe it was already gone. It was faint, it was fast, and the window to collect data closed quickly. By early 2018, Oumuamua was already too faint for most telescopes. The visitor had done what interstellar visitors do. It passed through, it left, and it left behind a set of measurements that were suggestive enough to keep arguments alive. In the quiet of the late hours, it is worth holding two ideas at once. The first is that science is often messy at the edge of observation. When data is limited, models can multiply. The second is that human minds love the idea of a message from elsewhere, not because it is likely, but because it is meaningful. A rock from another star system is already astonishing, even if it is only rock. After Oumuamua faded, surveys continued. Astronomers knew they had seen one. That meant there would be another, and in 2019, another arrived. This second visitor was different. It looked like what many scientists expected an interstellar object to look like. It behaved like a comet. Its name was 2I Borisov. The 2I part meant the second confirmed interstellar object. The Borisov part honored the astronomer who discovered it, Gennady Borisov. Borisov was found in August 2019. Unlike Oumuamua, which was discovered after its closest approach to the sun, Borisov was spotted earlier on its inbound path. That gave astronomers more time. More time means more data, and more data means fewer open holes for speculation. Borisov showed a coma. It showed a tail. It was clearly outgassing. In that sense, it was almost a relief. This was an interstellar object that looked like a comet. The orbit was again hyperbolic. The speed again implied it was unbound. But the physical behavior fit a familiar pattern. Scientists observed its chemistry and dust. They compared it to comets from our own solar system. One of the big questions was whether interstellar comets would look similar to ours or very different. Borisov seemed broadly similar in many ways, though it also had differences. Its composition, the ratios of certain gases, and the nature of its dust were studied. The key point for our story is that Borisov did not ignite the same kind of mainstream alien spacecraft speculation. It did not need a hidden thruster to explain its motion. It did not require exotic shapes to fit its light curve. It was strange because it was from another system, but it was not strange in the way that triggers 1,000 headlines. And yet, even Borisov can be used to hold the larger question. If natural interstellar comets exist and we can see them, then interstellar debris is real. The galaxy is not sealed. Material moves between star systems. That simple fact can be unsettling, because it means the solar system is not an isolated room. It is a hallway, doors open, things pass through, and sometimes we only notice after they are already in the middle of the corridor. After 2019, astronomy entered another phase. Surveys improved. New instruments were planned. The Vera C. Rubin Observatory, with its legacy survey of space and time, was expected to transform the rate of discovery for moving objects. With better coverage, scientists hope to find more interstellar visitors, perhaps several per year. That is what many models predicted should be possible with the next generation of surveys. In the years after Oumuamua and Borisov, the public was primed. The idea of interstellar objects entered popular awareness. News organizations had a new template. If an odd object was seen, people could ask, "Is it another one?" And sometimes rumors moved faster than the data. This brings us to the third name Raphael mentioned, 3I Atlas. Here we need to be careful. The designation 3I would mean the third confirmed interstellar object. And Atlas is the name of a real survey system, the Asteroid Terrestrial Impact Last Alert System. Atlas is designed to scan the sky for near-Earth asteroids and other transient objects, so it is easy to imagine a headline that combines these terms. A fast-moving object, a survey called Atlas, a label that sounds official, and a public already tuned to the mystery. In this kind of environment, a story can form before the facts are fully settled. Sometimes, an object is first reported as a possible interstellar candidate. Then, further analysis shows it is not, or it is a long-period comet bound to the Sun, or the early orbit fit was too uncertain. The truth is that the path from candidate to confirmed can involve multiple iterations. When only a few observations exist, the orbit is not locked in. As more data comes in, the uncertainties shrink. Sometimes, a hyperbolic orbit becomes less hyperbolic. Sometimes it stays. The public often sees only the first wave. Possible interstellar object detected. Then, later, a smaller correction. Actually, likely from the outer solar system. But the first wave is what sticks. This is part of why the alien spacecraft twist remains attached to the topic, because the gap between early uncertainty and later clarity is where imagination lives. For this episode, we will treat the idea of 3I Atlas as part of the cultural story, how people talk about interstellar visitors, how rumors travel, and how the desire for a dramatic explanation can shape what we think we saw. In other words, even if a specific object was not confirmed as 3I in an official sense, the pattern is real. A candidate appears, the label spreads, the alien interpretation follows, and then science does its slower work. It checks, it refines, it decides. Now let's step back and map the three interstellar objects that are truly the backbone of this history. First, 1 Oumuamua, the object that looked like an asteroid, moved like something slightly pushed and left too fast to be fully pinned down. Second, 2I Borisov, the comet that behaved like a comet and gave us a more classic interstellar case. Third, the idea of a third interstellar object, whether it is eventually confirmed under a formal 3I designation or exists for now as a set of candidates and rumors, showing us how this story now repeats. The documentary thread is not only the objects, it is also the human response. Because the human response is consistent. We see a visitor, we measure what we can, we argue about what it means, and we add the question of intelligence, because it is the most dramatic question we can ask. To give this story a clear backbone, we can walk through the life cycle of discovery. First comes detection. A survey telescope takes images. A moving point is noticed. Software tries to link observations overnight. A preliminary orbit is computed. At this stage, the orbit might be wrong. Not wrong in the sense of careless, but wrong in the sense of incomplete. 1 or 2 nights of data can allow many possible orbits. More observations narrow it. Once the orbit is good enough, astronomers can classify it. Is it a near-Earth asteroid, a main belt asteroid, a comet, or a visitor on a hyperbolic path? When a hyperbolic path is suggested, the object becomes a high-priority target, because you might only get one chance. You also need to ask whether the hyperbolic orbit is truly interstellar. It is possible for solar system objects to have slightly hyperbolic orbits due to measurement error or gravitational encounters, but a strongly hyperbolic orbit with speed that makes it clearly unbound points to an interstellar origin. Then comes physical observation. Astronomers measure brightness. They measure color. They look for a coma. They track rotation by observing how brightness changes. They take spectra to detect gases. They compare results to known objects. At every stage, the limits matter. The object might be too faint. It might be too close to the sun from our line of sight. It might be moving too fast. And all of this creates incomplete data. Incomplete data is not a failure. It is the normal state of exploring new territory. But in the public mind, incomplete data is a gap, and gaps invite stories. The alien spacecraft twist is one of those stories. It is not the only one. Sometimes the twist is ancient artifact. Sometimes it is government cover-up. Sometimes it is secret mission. But with interstellar objects, the alien twist has a clean hook. These objects are literally from beyond. So people ask, beyond what? Beyond the solar system? Beyond human control? Beyond our ability to predict? In the case of Oumuamua, the alien idea was not only emotional, it tried to attach itself to a physical mechanism. Radiation pressure, a thin sail, a controlled craft. Even if those ideas are unlikely, the structure of the argument matters. It shows how modern speculation tries to dress itself in modern physics. It is not just, I feel, it is aliens. It is, this acceleration could be explained by a sail. That makes it more compelling to some people. Now, to keep our narration honest and documentary, we can phrase it this way. When Oumuamua was observed, scientists proposed natural models. Some models fit parts of the data. Some left questions. A minority suggested that an artificial possibility should not be dismissed without consideration. The broader community remained skeptical. No definitive evidence of artificial origin was found, and the object left. That is where the story rests. A mystery that is real, but not necessarily supernatural. A question that can be asked, but not answered from the data we have. If you want an alien spacecraft twist, the honest twist is this. The galaxy is old, older than humanity. If intelligent life exists elsewhere, it could have launched objects long ago. Those objects could travel. They could pass through. The chance might be tiny, but it is not logically impossible. And because interstellar objects are real, the category exists. So the imagination has a real stage to stand on, not a fantasy stage, a stage built from real orbits and real observations. That is why people cared. Because it was not just a story. It was a story tied to a graph, a story tied to a telescope image, a story tied to numbers. Now, let's return to the details of each known case, with a calm, steady pace. In the autumn of 2017, Pan-STARRS was doing what it always does. Night after night, it scanned, it compared, it flagged. When the moving point was recognized, it was first given a designation like other small bodies. Then the orbit analysis changed the meaning. The hyperbolic trajectory made it special. This is a moment worth slowing down for. because it shows how discovery can be quiet. A computer flag, a scientist checks, a line is drawn on a plot, and suddenly a new category of object exists. After that, telescopes around the world pivoted. They pointed toward Oumuamua. They measured its light. One of the most famous measurements was the light curve. Brightness swung up and down, suggesting a tumbling motion. Tumbling is a sign of a past collision or disturbance. Many small bodies tumble, but the amplitude of the swing suggested an extreme shape. Then came the acceleration analysis. As positions were tracked, small deviations were noted. The simplest force beyond gravity is outgassing. But if outgassing is the cause, why not see a tail? This is where scientists began to explore more subtle forms of outgassing. Not all outgassing produces a dramatic dust tail. Some gases can be released with little dust. Hydrogen, for example, is hard to detect. Some models propose that if the object had a crust of certain ices, it could release gas in a way that creates thrust without a bright coma. Other models focused on the structure. A porous body might behave in unexpected ways. A fragment of a larger body might have a strange aspect ratio. A flat shape might reflect sunlight differently. In each model, scientists tried to respect the data, but the data was thin. Thin data can support multiple models. This is not because science is weak. It is because the object was not close for long. The cosmic visitor did not pause. The public saw that as drama. Scientists saw it as a lesson. If you want to understand interstellar objects, you must detect them earlier. You must have rapid response. You must have better surveys. You must be ready. This readiness became part of the motivation for future projects. When 2I Borisov was discovered in 2019, the response showed that learning. Follow-up came fast. The object was observed in many wavelengths, and because it was a comet with a clear coma, the physical interpretation was simpler. It was a dirty snowball, likely formed around another star. It carried dust and gas. Its chemistry could be compared to our comets. Some differences were found, but the overall behavior fit. This is important for the documentary view, because it shows that interstellar objects can be ordinary in form. The extraordinary part is their origin, not their physics. Borisov also reminded observers that interstellar objects are not necessarily rare. They are rare in our telescopes, but that does not mean they are rare in space. Our detection was the bottleneck, not their existence. Now, when people talk about the third interstellar object, they are talking about something bigger than a single rock. They are talking about a trend. They are talking about the future. They are talking about the day when interstellar objects are discovered routinely. And in that future, one of those objects might again behave oddly. It might again lack a clear tail. It might again show some subtle acceleration. And the alien spacecraft idea would return, because the template already exists. The phrase alien spacecraft does not just mean a flying saucer. In modern discussion, it can mean many things. A probe, a sail, a fragment of technology, a piece of debris, even a dead artifact. And the reason people can imagine that is because technology is now real. We launch spacecraft. We use solar sails. We send probes. We think about interstellar travel. So the mind asks, if we do it, could others? From a documentary perspective, the best way to handle this twist is to keep it grounded. We can say what people thought. We can say why they thought it. We can say what evidence existed. We can say what evidence did not. And we can admit what remains unknown. Now, to make the narrative flow, we can move through 3 layers. Layer 1 is the objects. Layer 2 is the instruments and the discoveries. Layer 3 is the public reaction and the alien idea. Let's deepen Layer 1 by returning to the physics of hyperbolic orbits in a gentle way. An orbit is a path defined by energy. If an object has negative orbital energy relative to the Sun, it is bound. If it has positive orbital energy, it is unbound. That is the mathematical heart of it. You can also see it in speed. At a given distance from the Sun, there is a speed above which you escape. Interstellar objects are already above that. This means they are not captured. They are only deflected. In the case of Oumuamua and Borisov, their trajectories told us their past and future. They came from a direction in the sky. They passed near the Sun. They left in another direction. If you trace those lines back far enough, you can try to guess where they came from. But the galaxy is full of stars. Over millions of years, small uncertainties grow, so identifying a specific home star is difficult. Still, the idea is powerful. These objects are travelers whose home is unknown. Now, Layer 2, the instruments. Pan-STARRS was the key instrument for Oumuamua. Atlas is a key instrument in modern surveys as well. Many surveys exist. Each has strengths. Some cover large areas quickly. Some go deep. Some focus on near-Earth threats. Some focus on transient events. Interstellar objects are found by the same basic method: repeated imaging and motion detection. The future, especially with Rubin, is expected to increase discovery rates. And with increased discovery rates, the third confirmed interstellar object will likely come. When it does, the label 3I will be applied. Until then, candidates and rumors will continue to appear. Now, Layer 3, the human response. To understand why people attach the alien idea to Oumuamua, it helps to understand what was new. Before 2017, interstellar objects were mostly theoretical. After 2017, the theoretical became real. That transition matters. It changes what you can honestly imagine. It is one thing to imagine aliens visiting. It is another to see a real object on a real, unbound orbit. Then the imagination says, if it is possible for natural objects, then it is possible for artificial ones. Again, not likely, but possible, and possible is enough for some people. Now, let the pace slow even more. Imagine the solar system as a dark ocean. Most nights, nothing new enters. Then, in the distance, a small shape moves. Not orbiting, not lingering, just passing. Our instruments catch a glint. We point our eyes. We try to make sense of a guest who refuses to stay. That is the emotional shape of this story, and it fits the quiet archive tone, not because we will make it mystical, but because it is naturally strange, because it is real. Now, to build the full 2-hour documentary-style narration, we will widen our view. We will talk about what we know about ejection from other star systems. We will talk about how a small object can be thrown out. In our own solar system, we have examples. Jupiter and the other giant planets can fling comets. When a comet swings close to a giant planet, the planet can change its orbit. This is called a gravitational assist. For spacecraft, we use it intentionally. For comets, it happens naturally. Some comets are thrown into shorter orbits. Some are thrown outward. Some are ejected completely. Now imagine that process happening around other stars. Many stars have giant planets. Many star systems likely eject debris. Over billions of years, the galaxy fills with wandering objects. These objects are called interstellar planetesimals. They are not planets. They are the building blocks that never became planets, or they are fragments of larger bodies. The sizes can vary. Some could be meters, some could be kilometers, some could be larger. We do not know the full distribution, but the discovery of Oumuamua suggested that there could be many, because to detect one by chance, you might need a large underlying population. That inference itself became part of the scientific discussion. How many interstellar objects are out there? What does one detection imply? What does two imply? What will three imply? Then, again, the alien twist. If the population is large, then even a tiny fraction of artificial objects could still mean something. This is the logic some people follow. But it can also be misleading, because we do not know the artificial fraction. It could be zero, and the simplest position remains that natural objects dominate. Still, the story is about why people thought what they thought, so we will keep that thread alive. Now, let's create a calm timeline. 2017. An object is discovered. Orbit analysis reveals it is interstellar. Its brightness variation suggests an extreme shape. A small, non-gravitational acceleration is reported. The lack of a visible tail drives debate. The public takes notice. A few scientists discuss the possibility of an artificial origin. Most propose natural mechanisms. The object fades. The debate remains. 2019. A second interstellar object is discovered. It is a comet. It shows a coma and tail. It is observed in detail. It is less mysterious in behavior. It confirms that interstellar visitors can be detected and studied. The topic becomes part of mainstream astronomy. The public interest continues, but without the same intensity of the alien spacecraft narrative. After 2019, the idea of a third interstellar object becomes a recurring headline. Candidates are discussed. Some are promoted too early. Some are later downgraded. The label 3i is anticipated, and the cultural response is now ready. Now, a listener might ask, why does this matter beyond curiosity? It matters for several reasons. One is scientific. Interstellar objects carry information about other systems. They are samples, not collected by a spacecraft, but delivered by gravity. We can study their composition. We can compare them to our own comets and asteroids. We can learn whether the building blocks of planets are similar elsewhere. Another reason is practical. Interstellar objects move fast. If one were large and on a collision course, it would be harder to detect early. That is a planetary defense thought, not a panic, just a reminder. The sky contains things that do not belong to our family. A third reason is philosophical. Interstellar objects make the boundary between us and the galaxy feel thin. They remind us that space is not empty. It is a medium. It is a place where matter travels. And in that medium, our solar system is a waypoint. Now, with that frame, we can gently return to Oumuamua, because it remains the object that carries the alien twist most strongly. Avi Loeb's argument, as it reached the public, was not a claim of certainty. It was a claim about openness. He suggested that scientists should not dismiss the possibility of artificial origin purely because it sounds strange. He also suggested that if the object were thin and reflective, sunlight could push it. Sunlight does push. This is real physics. Solar sails are real. We have flown them. So the idea is not impossible, but the leap is from possible to probable. Most scientists do not take that leap They point out that natural explanations, while imperfect, are still more likely. They also point out that extraordinary claims require extraordinary evidence, and we did not have extraordinary evidence. We had limited data. We had a strange object. We had a discussion. That is the honest documentary state. Now, because this is a long-form narration designed for sleep, we can let the details become a slow tide. We can revisit the measurements calmly. We can describe how an astronomer might see the data, a set of points, a curve, a small residual, a debate about error bars, and behind all of that, the silent reality, a small object already far away, still moving. Now we can also look at what was not possible. We could not send a spacecraft, not in time. Even if we wanted to, the planning would be too slow. The object was moving too fast. This led to real proposals for the future. Some scientists proposed that if we detect an interstellar object early enough, we could launch a fast intercept mission. A mission like that would be challenging, but it is not science fiction. It is engineering. If such a mission were possible, it could answer questions that telescopes cannot. It could measure directly. It could take images close up. It could sample dust. It could measure gases. It could remove ambiguity. And it could, in principle, rule out artificial features if none were present. Until then, we have the sky and our instruments. Now, let's speak gently about what alien spacecraft means in the public imagination. For many people, the phrase is shorthand for a deeper feeling. The feeling that we are not alone. The feeling that the universe is watching. The feeling that something could enter our space at any time. Interstellar objects are not evidence for that feeling, but they are compatible with it. That is what makes the twist stick, because it is not proof. It is a doorway that the mind wants to walk through. Now, if we want to keep the narrative responsible, we can make the twist about belief rather than about certainty. We can say people thought it could be. We can say, here is why. We can say, here is what scientists argued. We can say, here is what remains unknown. And we can keep returning to the simple fact. A visitor came. It was real. It was from another star system. And that alone is enough to change our sense of the cosmos. Now, to keep this episode full and detailed, we can expand into the wider history of how astronomy learned to recognize unbound objects. Long before 2017, astronomers had seen hyperbolic comets, but most were only slightly hyperbolic, and many were influenced by planetary encounters. Some were thought to be from the Oort cloud, a distant reservoir of comets around the solar system. The Oort cloud is not directly observed, it is inferred. It is a theoretical shell of icy bodies far beyond Pluto. Long-period comets are thought to come from there. When they fall inward, they can appear with high speed and long, stretched orbits. Some may have eccentricities slightly above one due to uncertainties. This is why a robust interstellar claim requires strong evidence. It is not enough to see a number barely above 1. You want to see a clear, confident hyperbola. Oumuamua provided that. Borisov provided that. And future objects will need to meet that standard. Now, the phrase tracked in history can also be understood as tracked by our instruments. Because in a deeper sense, interstellar objects have likely passed through the solar system many times in the past. We just did not notice. Our surveys were not wide enough. Our cameras were not sensitive enough. Our computing was not fast enough. So the history we tell is short. It starts in 2017, it continues in 2019, and it waits for the next confirmed visitor. That short history is still meaningful because it marks a transition. The universe did not change. We changed. We gained the ability to see. Now let's return to the idea of the third object again, because it sits at the intersection of science and rumor. When surveys detect a new object, orbit determination begins. At first, the orbit can look hyperbolic. An early fit might suggest it is unbound. Then, after more observations, it might move into a bound category. This can happen. So when people say Three-Eye Atlas or share a headline about a third interstellar visitor, the truth might be that the object was a candidate, not a confirmed case. The documentary lesson here is that science is a process. A label is not a final truth. It is a step. But the public often hears the label as final. This is not because the public is foolish. It is because the machinery of information favors first reports. First reports are exciting. Corrections are quiet. In the context of alien speculation, the first report is what feeds the twist, because possible interstellar becomes definitely interstellar, and definitely interstellar becomes maybe artificial, and maybe artificial becomes alien probe. The steps are not logical, they are emotional. Now, there is another aspect of the alien twist that is subtle. If you suspect an object might be artificial, you might look for signs of control. For example, changes in acceleration that do not match outgassing, or changes in brightness that suggest a structured shape, or signals. But we did not detect signals from Oumuamua, and we did not see evidence of controlled maneuvering. We saw a small acceleration that could fit natural models. So the best documentary conclusion is that the alien spacecraft idea was a public and minority scientific speculation, not a confirmed result. Still, it captured attention, because attention follows the most dramatic branch. Now, to keep the story full, we can explore what an interstellar object might look like if it truly were artificial. It could be a sail, it could be a probe, it could be a fragment. It might have a non-natural shape. It might reflect light in a very regular way. It might show a spectrum that suggests metals. It might show flat surfaces. It might transmit. But even here, caution is needed, because nature can produce strange shapes. Collisions can produce shards. Tidal forces can stretch objects. Porous bodies can have unusual behavior. So strange does not equal artificial. Now, let's return to the calmer factual track. A key number often mentioned with Oumuamua is its speed relative to the sun. It arrived with a velocity that suggested it was not bound. It also had a velocity relative to the local standard of rest that was not extreme. Some people noted that it was moving roughly with the average motion of nearby stars. To some, that seemed curious. To others, it was simply plausible. Again, the same pattern. A fact, a possible meaning, a debate. Now, in the case of Borisov, measurements were more straightforward. It was a comet. It released gas. Its dust was studied. Its nucleus size was estimated. It was likely a few hundred meters across. It passed through, and it left. Borisov gave us confidence that interstellar comets are real and observable. It also gave us a comparison point. If the next interstellar object looks like Borisov, the alien twist will likely be weaker. If the next one looks like Oumuamua, the twist will flare again. Now let's take a long, slow breath in the middle of this story, because the central emotion of the topic is a sense of arrival, a visitor, a messenger, something that has been traveling for millions of years. Then, for a short window, it is close enough for human eyes, and then it is gone. That is a natural shape for a quiet archive narrative, because it is about time and distance and the thinness of our moment. Now, as we continue, we will keep looping back to the three names: Oumuamua, Borisov, and the third, the one that is still half fact and half anticipation. We will also keep looping back to the twist, not as a claim, as a cultural echo. Now, to add more documentary depth, we can discuss how names and designations work. When an object is discovered, it receives a provisional designation based on date and discovery order. If it is a comet, it gets a comet designation. If it is an asteroid, it gets an asteroid designation. For interstellar objects, a new system was created. The eye designation was introduced. So Oumuamua became one eye. Borisov became two eye. The third would become three eye. This naming system matters because it formalizes the category. It marks a boundary. This is the moment when interstellar objects became a recorded part of human catalogues. Now let's consider what it means to have only two confirmed cases. Two is not much. With two, you cannot map a distribution. You cannot generalize strongly. But you can start to ask questions. Are most interstellar objects comet-like or asteroid-like? Are they mostly small, or can they be large? How often do they pass? How many do we miss? Do they come from certain directions? Do they come from certain kinds of stars? In the future, these questions will become more answerable. But for now, the history is short. And that shortness is part of the story, because it leaves room. Now, let's make room for a gentle speculative segment that fits the alien twist without breaking documentary integrity. Imagine a civilization far away. It launches probes. It launches sails. Not to visit Earth specifically, but to sample the galaxy. Some of those objects drift. Some pass through other systems. Could one pass through ours? Yes. But would it be likely that the first two we see are artificial? Probably not. Still, could one of the many we will see in the future show signs? Maybe. And that is the honest place to hold the twist. Not it was, but it could be possible in principle, and Oumuamua made people ask. Now, to keep the narration long and steady, we will keep repeating the core timeline, adding detail each time. In 2017, the discovery of Oumuamua happened because survey technology reached a threshold. In 2019, the discovery of Borisov happened because the sky was being watched more carefully. In the next decade, the discovery of the third confirmed interstellar object will likely happen because new surveys increase the watchfulness even more. Now, we can also add a small, calm segment about how brightness is used to estimate size. When you see a faint point of light, you do not know if it is small and reflective or large and dark. To estimate size, you need assumptions about reflectivity, called albedo. If an object is bright for its size, it has a high albedo. If it is dim for its size, it has a low albedo. For interstellar objects, we may not know the albedo. So size estimates have uncertainty. This is why early discussions of Oumuamua's size varied. We could estimate it might be tens to hundreds of meters, but the exact number depended on assumptions. Again, uncertainty. Again, room for speculation. In the public mind, uncertainty can become exaggeration. It could be huge. It could be a ship. But in the scientific mind, uncertainty is a range. Now, to return to the calm, the object is gone. Only the measurements remain. Now, because we need to fill a long duration, we can expand with historical parallels. For example, consider how comets were once interpreted. In ancient times, comets were seen as omens. They were strange. They appear suddenly. They moved. They vanished. They frightened people. Over centuries, science reframed them. They became natural objects. And yet they never fully lost their emotional charge. Interstellar objects are similar. They are natural objects, as far as we can tell. But they feel like omens. Not because they predict events, but because they point to a larger reality. A reality where the solar system is not closed. Now, we can also discuss the idea of panspermia, the hypothesis that life can travel between star systems on rocks. Interstellar objects bring this idea back into focus. If rocks travel, then in principle, microbes could travel. This is speculative, but it is another reason interstellar objects matter. They are potential carriers, not of aliens in spacecraft, but of chemistry, of organics, of the building blocks of life. This layer adds depth because it shows that alien does not have to mean intelligent. It can mean foreign. It can mean chemistry from elsewhere. Now, we can return to the main three again. Oumuamua, the strange one, Borisov, the classic comet, and the third, the anticipated one. Now, to keep our style simple, we can present each object as a chapter without using chapter headings. We can say in plain language what happened. We can keep the listener oriented, and we can keep the pacing slow. So let's spend a long stretch on Oumuamua. In the images, it never looked like a spaceship. It looked like a dot that moved. The alien twist lived in interpretation, not in a photo. This is important because it shows how much human meaning can be placed on a faint signal. The light curve became a kind of Rorschach test. The acceleration became a puzzle piece. And because the object vanished quickly, the puzzle could not be completed. This is why the story persists, not because we found proof, but because we lacked closure. Now, spend a long stretch on Borisov. Borisov was less mysterious. It was still historic. It was still from beyond. But it was a comet. It had an explanation we already knew. It was like meeting a stranger from far away and finding that they still speak a language you can understand. That is a gentle way to think of it. Now, spend a long stretch on the third. The third is not one object in this narration. It is the idea of the third. It is the way the media now hunts for it. It is the way the internet now labels it. It is the way a survey name like Atlas can be folded into a dramatic phrase. And it is the way people will react when the next one comes. Because the reaction has been rehearsed. Now, to keep the episode long, we can add more detail about surveys. Pan stars, Atlas, Rubin. Each survey has a cadence. Cadence is how often it returns to the same patch of sky. A faster cadence means you are more likely to catch fast-moving objects. A deeper survey means you can see fainter objects. Interstellar objects are often faint, so you want depth, but they are also fast, so you want cadence. The ideal survey does both. Rubin is designed to do both at scale. This is why many scientists expect more interstellar discoveries soon. Now, for the alien twist, more discoveries might reduce mystery. If we see many interstellar comets, they become normal. But if we see a variety, the odd ones will stand out. The odd ones will attract attention, and the alien narrative will attach again. Now, to keep the listener engaged in a calm way, we can add a small, simple description of what a spectrum is. When you split light into colors, you can see lines. Those lines tell you what chemicals are present. For comets, lines can reveal gases like carbon monoxide, carbon dioxide, cyanide, and water-related products. Borisov's spectrum was studied. It showed that it was a comet with familiar chemistry, though not identical to our comets. This supports the idea that planet formation processes are broadly similar. And again, this is a deep cosmic point. We are made of common matter. The galaxy shares building blocks. Interstellar objects are pieces of that shared process. Now, we can also address the question of how many interstellar objects have we tracked. In the strict sense, the confirmed number is 2, Oumuamua and Borisov. In the broader cultural sense, many candidates have been discussed. Some are later reclassified, but the 2 confirmed remain the anchors. In this episode, we treat the topic as 3 stories, 2 confirmed objects, and the cultural story of the 3rd. That structure lets us satisfy the request while staying honest. Now, because we need to reach a long word count, we continue deepening the narrative with calm repetition and additional context. Consider the timescales. An interstellar object might travel for millions of years. It might pass near many stars. Most of the time, nothing happens. It drifts. Then, once it passes near a star system, if it passes close enough to a planet, its path can change. If it passes close enough to a star, it heats. If it contains ice, it may release gas. If it is rocky, it may simply warm. Then it leaves. Our encounter with it is a moment, a short overlap between its long journey and our short ability to observe. Now imagine that in the future, humans send their own interstellar objects, small probes, sails, messages. If that happens, those objects will also drift. They will also pass. They may also be seen by others. This symmetry is part of why Oumuamua captured attention. It felt like a mirror. Now, bring the mind back down to the practical. We did not see bolts or panels. We saw a dot. We inferred a shape from a light curve. We inferred an acceleration from orbital fitting. We argued. We wrote papers. We debated in public. And then we waited. That waiting is ongoing, because the next interstellar object could appear tomorrow, or next year, or later, but it will appear. Now, to maintain documentary style, we can mention key names and institutions, but not overload. Pan-STARRS, Minor Planet Center, International Astronomical Union, Atlas, Rubin. These are the machinery behind discovery. Without them, the visitors would pass unseen. Now, we can also gently describe how orbit fitting works. You observe the object's position against the stars. You record time. You record coordinates. You do this over multiple nights. You fit a curve. You account for Earth's motion. You account for gravitational forces. You estimate the object's trajectory. If the fit yields an eccentricity well above 1, you have an interstellar candidate. If the fit yields something near 1, you need more data. Now, again, the gap between candidate and confirmed is where rumor lives. This is where the phrase 3i Atlas can arise, not as a lie, but as a premature label. Now we can also mention that survey names can be mistaken for object names. Atlas is a survey. An object discovered by Atlas might be given a designation with letters and numbers, but the public may call it Atlas. This is normal. We call comets by the name of their discoverer. We call objects by mission names, so calling a candidate Atlas is plausible, and adding 3i makes it sound official. Now, because the user request wants that twist, we can highlight how this labeling helps the alien narrative. An official sounding name gives authority to speculation. It makes the story shareable. Now, to keep this episode long, we can also talk about how data is archived. Observations are stored, orbits are updated, papers are published, public arguments happen, but the archive remains. In the quiet archive style, we can imagine reading these records: a list of measurements, a curve, a note, Interstellar. Now, because the episode needs a closing, we will eventually return to the idea that these visitors are real and that the story is ongoing. Before that, we continue weaving. There is also an important point about selection bias. We discovered Oumuamua and Borisov because they were detectable. There could be many smaller interstellar objects that pass unnoticed. There could be larger ones that pass in directions we do not survey well. There could be objects that come close to the sun and are lost in glare. So our history is shaped by our limits. Now, if you want an alien twist, selection bias can also be used in speculation. Someone might say, maybe we only notice the strange ones, but in reality, we notice what we can. Now, to keep the style simple, we avoid complex math. We speak in plain images: a doorway, a hallway, a guest, a passing ship of rock and ice. Now let us settle into a long, steady recitation of the known facts about Oumuamua. It was discovered in October 2017. It had already passed perihelion, its closest approach to the sun. It was on a hyperbolic orbit. It appeared reddish in color, like some outer solar system objects. It showed a tumbling rotation. Its brightness varied strongly. A non-gravitational acceleration was reported. No strong cometary activity was seen. It was observed for a limited time. It faded. It left. It remains the most debated interstellar object. Now, the known facts about Borisov. It was discovered in August 2019. It was confirmed to be interstellar by its hyperbolic orbit. It displayed a coma and tail. It behaved like a comet. It was observed for months. Its composition was studied. It left. It remains a strong example of a natural interstellar comet. Now, the known facts about the third. A third confirmed interstellar object had been anticipated. Candidates have been reported. Some were later reclassified. The public often attaches dramatic interpretations. The next confirmed discovery will likely trigger another surge of attention. Now, to further fill the episode, we can examine the social dynamics around Oumuamua. When a scientific paper suggests an artificial possibility, it spreads quickly. It becomes headlines. It becomes arguments. People pick sides. Some accuse skeptics of being closed-minded. Some accuse speculators of chasing attention. This is a familiar human pattern. Science becomes a stage for deeper cultural conflicts. But the object itself does not care. It continues on its path. Now, because this is a sleep story, we can let those conflicts soften. We can treat them as part of the record, not as a fight, just as a human reaction. The visitor came, humans argued, the visitor left. Now we can end with a gentle sense of openness. The sky will send more visitors. We will be watching. And whether they are only rock and ice or something stranger, the truth will be written in the quiet archive of measurements. We can imagine future astronomers reading the record. The first interstellar object, the second, the third, and beyond. For now, we have 2 anchors and a horizon, 2 confirmed visitors, and the expectation of more. Now, as the narration slows toward the end, we return to the central theme. Interstellar objects are real. They are the galaxy brushing against our solar system. They are reminders that space is connected. They are, in their own way, a kind of message. Not a message written in language, a message written in orbit. A message that says, you are not sealed off. And that is enough to make people wonder, to make people imagine, to make people whisper about alien spacecraft, and to make scientists build better telescopes. The story continues. The next visitor could arrive without warning. A small point of light, a quick curve, a hyperbola, a brief chance to look, and then, again, the long drift into the dark. And as we come toward the end of this record, it helps to look forward in a calm, practical way. The next wave of surveys will not just find more asteroids, it will find more of everything that moves. When the sky is scanned deeply and often, the rare becomes less rare in our data. A third confirmed interstellar object will likely be found, not because the universe changed, but because our search became steady enough to catch it early. If we catch it early, we might do something we could not do for Oumuamua. We could watch it for months before and after its closest approach. We could measure its color and shape more precisely. We could check for a coma with better sensitivity. We could see if any non-gravitational acceleration appears, and if it does, whether it matches the signature of gas jets, and if the object still behaved in a way that resisted simple explanations. The debate would return. The same arguments would appear. Some would say nature has many strange tricks. Others would say the door to the artificial should remain open. Most would say the answer should follow the evidence. In the quiet archive view, that is not a conflict. It is a process. The universe sends a small visitor. We gather what we can, we store it. We compare it to what came before, and we wait for the next. For now, the historical record is short. It begins with Oumuamua, the first confirmed interstellar object, strange in its shape and in the way it seemed to drift. It continues with Borisov, the second confirmed visitor, a comet that looked more familiar and gave us clearer physical clues. And it stretches into the present with the expectation of the third, sometimes spoken of with labels like 3i and names like Atlas in early chatter, showing us how quickly the modern world builds a story around a moving point of light. If there is an alien spacecraft twist to keep, it can be kept in one honest sentence. When Oumuamua passed through, the world briefly wondered if a visitor from another star might be more than a rock. That wonder was not proof, but it was real, and it will likely return the next time a true interstellar object behaves in a way we do not fully understand. Until then, the simplest truth remains enough. Space between the stars is not empty. It is full of travelers. Most are silent, most are natural. But every so often, one crosses our path, and for a short moment, we get to measure a piece of another system. We watch, we record, and we let it pass. This was a quiet archive story, where the story ends, sleep begins,